Hey guys, Professor Moore back here for another video, and inside this video we're going to be talking about the pH scale. Pretty much what the pH scale is that it's a universal scale which ranges from 0 to 14. And what it pretty much tells us is if something's acidic, a basic, or pure. And it can also help us if something's aqueous, solid, or a liquid, for example. And sometimes it can even help us determine a gas. And pretty much, this is the main purpose of the pH scale. It just pretty much is the concentration of hydrogen to hydroxide ions. And to define the pH scale, we have three categorizations. Well, we have 0 to 6, we have 7, and then we have greater than 7, so that can range between 8 to 14. Technically, this also ranges from decimal numbers, but rather than talking about decibels, we're just going to be talking about whole numbers in this video. So, with the general categorization for 0 to 6 movie, let's just move over. So, 0 to 6 is going to be the acidic set of pH scale. So, it's going to be acidic. And when something's acidic, pretty much what it's going to be letting us know is that if hydrogen ions are greater than hydroxide. And this is pretty much what acidic is telling us. It's telling us that, for example, in something like lemon, which is pH of 2, so pH of 2, that would mean pretty much that lemon has um, greater hydrogen ions. So let's talk about greater hydrogen. Yeah. And this is pretty much all that it's telling us, that lemon is pretty much just more concentrated with hydrogen ions than hydroxide ions. So now that we've covered 0 to 6, let's talk about 7. Well, 7 is pretty much just pure, so it's going to be the pure side of the pH scale. And what pretty much pure means is that hydrogen equals to hydroxide. So, let's get rid of that. So pretty much what it's telling us, let's say we have two hydrogen ions. That means in 7 it would also have two hydroxide ions, and that's all it's telling us, that 2 and 2. And examples of pure could be something like sodium chloride. It could also be something like water, or pure water. And it could just have a certain set of other examples, but the main ones, which is used, is generally just pure water. That's the general categorization when it comes to uh, talking about pure sides of the pH scale, which is simply just 7. And once we've covered 7, now let's move on to the basic side of the pH scale. And pretty much the basic side is going to be greater than 7. So pretty much it's sorry. And so pretty much what it's going to be is that it's going to have hydroxide, and hydroxide is going to be greater than hydrogen. And this is going to be between 8 to 14. And this is all that 8 to 14 is telling us, that any element or any compound or any substance which is between 8 to 14 is just going to have a higher amount of hydroxide ions than hydrogen. But there could also be examples. So good examples would generally be something like bleach or ammonia. And even just normal soap. These would all be examples of basic substances, and it all shows that hydroxide ions are greater than hydrogen ions inside these substances. But not all substances are as basic as each other, so something with a pH of, for example, 9 is not equal to basic, is not as basic as something with a pH of 14. Same thing with acidic elements. So we know that something with a pH of 1 is more acidic than something is more acidic than something with a pH of, for example, 4. And the way we know that is because the pH scale is more, it moves in steps. So every step that we take is to the power of 10. So pH 1 is greater than pH 2. And pretty much we're going to say that this is by times 10. So pH 1 is 10 times greater than pH 2. And then now when we move over, let's say pH 1 is going to be greater than pH 3, and then the difference now is going to be 100, because now we've moved by 2 steps, as we've learned that pH moves in power of 10. So pH 1 to pH 2 is that's times 10. This is going to be times 100. So this is going to be times 10. This is going to be times 100. And then the next one's going to be uh, 1,000 times stronger. So something of pH 4 would be 1,000 times less strong as pH 1. So pH 4 multiplied by 1,000 equals to pH 1's acidicness. And that's basically what the pH is telling us, that it moves in steps, and then every step is just a power of 10. At that point, I'm going to conclude this video, guys. I've hoped you've understood exactly what a basic element is, or a basic compound or a substance, what a pure substance is, and what a acidic substance is, and what the main purpose of the pH scale is. Remember, it's to identify if something would be acidic or basic or pure, and that's mainly the categorization. From those derivatives of acidic, basic, and pure, we can also have references if it's going to be aqueous or solid or liquid or a gas. If you guys have any questions, leave them in the comments below, and we'll Professor out.